Um, and so our big piece today, we'll just start with an example. Let's say we have some equation with the square root of x, and maybe we're adding 5 to it, and we'll set that equal to 13, okay? When we do these types of problems, your key, all right, or what your first goal has to be is get the radical, or in this case, the square root, get the radical by itself, okay? That's always got to be goal number one. So you're going to have to undo, all right, kind of work outside in order to get the radical by itself. So you guys would say, all right, if I want to get the square root of x by itself, well, let's just subtract 5 from both sides. And we'll have the square root of x equals 13 minus 5, or 8. Okay. And I doubt it's much of a shock to undo. You guys knew that when we had x squared, you undid it with a square root. So how would you undo a square root? What would you have to do to get rid of the square root? Does it make sense? We'd have to square things. We'd have to square
Yeah.
both sides. Okay. So that would leave us with just x equals 64. Okay.
Oh, okay.
All right. Because we took the squaring, a square root, those undo each other. And then 8 squared is 64. Notice it's not positive and negative 64. It's just regular 8 squared. Okay. Just 8 times 8, or 64. Okay. Again, our goal though was let's get the radical by itself. Okay.
Mm-hmm.
So let's try one more. And you guys, this one, you guys kind of talk me through what you think. All right, here's um, what I would do to try to get the radical by itself. We're just going to set 3 minus the square root of x. We're going to set it equal to 0. Okay. So again, just like before, our goal, get the radical by itself. So will you guys, somebody tell me, what would the first step be?
Subtract 3.
Okay, we can do that. Subtract, oops, I gotta get my pen. All right, so Bella wants to subtract 3, and that will work. So now we have the negative square root of x equals negative 3. Okay,
Divide off the negative.
yeah, all right. So if we divide off the negative, you could have had the square root of x equals 3. Some of you might have looked at this at the very beginning and said, instead of subtracting 3, I want to add the square root of x to both sides. And that's completely valid. We get exactly to where we are right here. Okay. So both methods work in that case. Okay. And so how would we, again, to undo a square root, what do we have to do?
Square it.
Yeah, we're going to square both sides. Okay. So x equals positive 9. And we could go back in to our original. We can always check it. Okay. If we were to do our check, we'd say, does 3 minus the square root of 9, does that equal 0? And we go, all right, square root of 9 is 3. 3 minus 3 equals 0. We're good. Oops, one thing's flipping. Okay. Questions on that? Does that seem pretty straightforward?
Mm-hmm.
Okay. Let's take it up a notch. I just want to start with a couple easy examples. Again, our big key is get the radical by itself. Once you do that, you're in really good shape. Okay. Let's go ahead and make this one a little bit harder. I'm going to give you guys, I'm going to go ahead and write it, and then we're just going to sit. I just want you to think for about 15 seconds. Hey, what would the steps I would take be in order to get the radical by itself? Okay. So just take a second, think in your head. All right. Okay. All right. So one person, give me just one step. What would the first thing you do be?
Subtract the 3.
Subtract the 3. Was that Brady? All right. Good. Brady's right. And Brady, why did you pick subtract the 3 and not divide by 4?
Because you have to get the what's it called, the loan first.
Say that again.
Yeah. You have to get the or what's it called, the loan.
Yeah. Okay, you want to get the radical or the square root sign by itself. And so what Brady's kind of doing, I didn't exactly say it, but he's doing it exactly right. You guys know how we talked about our order of operations. All right, you know, parentheses, exponents, multiplication, division, addition, subtraction. Again, we're working up this ladder. And so I'm going to just kind of put with exponents, I'm also going to put square roots. Okay, square roots kind of go with the exponents. Okay, and anything under a radical, we could kind of put in square roots or it's inside parentheses. Okay, so the exponents and the square roots, those kind of go together. So Brady's right. So we end up with what do you say? 4. All right, we have this guy equals 16. What do you guys? Somebody different. What will we do next?
Divide 4.
Yep, divide by 4. Okay, so we're left with the square root of x plus 2 equals 4. All right, somebody other than Brady and Bella, what next?
Would you square root it to cancel out? I mean, would you put a exponent of 2 to
Yes.
cancel out the square root?
Yes, you would put an exponent of 2 or squaring it. Those both mean the same thing. Good. Okay, and so those two pieces undo each other. So you're left with x plus 2 equals 16. Okay. And then obviously, yes, subtract the 2, and your final answer is x equals 14. You could go back to your very beginning. You would check it by plugging it in. And so if we did our little check, I'm just going to put our little check down here. 4 times the square root of 14 plus 2. Okay. Plus 3. Well, that's 4 times the square root of 16 plus 3. And the square root of 16 is 4. So 4 times 4 plus 3. All right. And in fact, that does equal 9. So this solution checks out. Okay. You guys tell me, just looking at that, based on what we've gone through, how do we feel about that on a scale of 1 to 5?
Like 4.
4s. 4 from Bella. What
4.
other people? It's okay if it's a 2 or a 3, even a 1. Like, all right, Mr. Jones, say back up. I just want a little feedback from you guys. Bella's saying 4. Somebody put something.
3.5.
3.5. Okay. Good. Tell you what, we're actually gonna go, because we got through that a little bit quicker. We're gonna do one more and then I'll send it over to you guys. Okay.
Mhm.
I'm gonna do one more example and then I'll send it over to you. What would happen? You guys know, all right, our goal, like you guys were pretty good at, get the radical by itself. What if we looked at an example like this though? All right, we say 2x minus 1, and where this one's gonna get tricky is we have a radical on both sides now. Do you see that?
Mhm.
Okay. So now our rule of, well, get the radical by itself. Well, what do we do? Okay. Well, we kind of did get the radical by itself. If we look at if we cover up the right side for a second, we did get this radical by itself. Okay. So let's go ahead and square both sides. Does that make sense? We
Mhm.
square both sides, that will get rid of, squaring undoes a square root. And so we're left with 2x minus 1 equals x plus 4. Okay. And you guys are pretty good at this point. This is stuff you probably did with Mrs. Goff in 7th, 8th grade. I'm not sure when exactly. Okay. And you can add 1 to both sides. You'll get x equals 5. Okay. And if we went to, oops, let me pull this over here. If we went to check it, we could say, all right, the square root of 2 times 5 minus 1. All right, and we're going to set that equal to the square root of 5 plus 4. Well, so that can simplify the square root of 9. And our first guy, 2 times 5 is 10 minus 1. Well, that's the square root of 9. So they both equal each other, or 3 equals 3. It checks out. So our answer works. okay? I just don't want you to freak out. If you see a radical on both sides like we had in our original problem, as long as there's nothing hanging off on the end, just go ahead and square both sides, okay? All right. That's all we're really doing today, okay? And we'll kind of continue with this conversation on Friday, but I want to give you guys a chance to practice, okay? So we got about, I told Treasure we'd be done by 2. So we got about 10 minutes. I'm going to give you guys 2 to 3 examples. We're going to start with 2, and we'll see how long it takes us if we get to a third one or not, okay? Well, go ahead, and if you got something to go ahead and jot these down somewhere, all right? Your 2 examples, number 1, okay, it's going to be 3 times the square root of x plus 5, not under the radical, we have a -1, and we're going to set that equal to 11. Oops. All right, the second example, example 2, oops, 2, all right, we are going to try, we're going to say the square root of 4x minus 3 equals the square root of x plus 9. All right, so that's 4x minus 3, and both of these are all under the radical. So go ahead and take a minute, go ahead and get those jotted down.